In this video, we're going to take a look at solving quadratic simultaneous equations algebraically. Now, hopefully by now, you are confident in solving simultaneous equations and you are familiar with the different ways that we can take to solve simultaneous equations. Now, in this video, we're going to take a look at the algebraic approach, so this is the method of substitution. In the next video, we'll take a look at the graphical approach to solving quadratic simultaneous equations. Now, let's just quickly highlight what we've actually got here. So what I've got here are simultaneous equations. This equation here actually represents a circle. So hopefully you recognize this form here. So this is x squared plus y squared is equal to r squared. Okay, and this is the equation of a circle. So my center here for this circle, so the center would be 0, 0. So it's centered at the origin. And my radius here will be the square root of 5. So r is equal to the square root of 5. Now, what I'm going to do is just quickly sketch this. And the reason we're sketching this is important. You don't actually have to sketch this, but I just want to highlight here what actually happens and why we get two sets of solutions. So if I sketch this, it's centered at the origin here, and it's going to look, say, something like that. Not perfect, but you get the idea. So that's my circle here. So that's x squared plus y squared is equal to 5. And this equation here is actually just the equation of a straight line. So if we put this into the form y equals mx plus c, then at this point here we need to subtract 1 off both sides, and I get y equals x minus 1. Okay? And if I sketch this here, this is going to look something like this. So it'll cut through the y-axis at -1. Let's say that's there. And it will cut through the x-axis at +1. Okay? And clearly this has a positive gradient. It's going to look something, say, like this. Okay? It's supposed to be a straight line, but that's the idea. Okay? So that's the equation for x equals y plus 1. That's the straight line here. And then I've also got x squared plus y squared is equal to 5. And that's my circle. Okay, so let's just note that as well. So why am I actually sketching this here? Well, the reason I'm actually sketching this here is to highlight that we get two sets of solutions. Notice that when these intersect here, I get this solution here and this solution here. So this is how we actually solve this graphically. And obviously we're not doing that in this video, but I want to highlight that we get two sets of solutions. Okay. So that's important to note. We should get two sets of solutions. So if we go back to looking at this now and taking an algebraic approach to this, well, we need to use the method of substitution here. So I've got my first equation, equation 1, and I've got my second equation, equation 2. Now notice for equation 1, this is quadratic, so I've got x squared, power of 2, I've got y squared again, a power of 2. So what makes sense here is to take equation 2 and rearrange it so either x is the subject or y is the subject, and then substitute that into equation 1. Now, given that equation 2 is already in terms of x here, or it's x is the subject, in that case, it makes sense to substitute x equals into equation 1. So what I'll do the algebraic approach now in a different colour just to highlight this. So what I'm going to do is substitute 2 into 1 here. So for x here, we replace that with y plus 1. So I get y plus 1 all squared. So y plus 1 all squared plus y squared. And that's equal to 5. Okay. We need to expand these double brackets here. So I've got y plus 1 times y plus 1. This y squared here, we'll take a look at that in a moment. And this 5 here, well, what I want to do is we don't want this to be equal to 5, we want this to be equal to 0. Okay, and when we're solving equations, we want it to be equal to 0. So what I'm going to do is I'm going to subtract 5 off both sides as well. Okay, and that's equal to 0. Expanding these double brackets here, well, any method of expanding double brackets is absolutely fine. So I'm going to get y squared. I'm going to get y times 1, so that's 1y. And we do the same here. So 1 times y, so that will also give me another y. So y plus y, that gives me 2y. And finally, 1 times by 1 gives me positive 1. Okay, so that's the double brackets expanded. Don't forget we've also got y squared here. So plus y squared. We've also got minus 5. And this is all equal to 0. And notice what happens here now is we get a quadratic equation that's in terms of y only. Okay, so essentially we've eliminated the x now. So if we collect like terms here, what I get is 2y squared. We get 2y squared, so y squared plus y squared. I've got 2y here and there's no other y, so that's just 2y. And then finally we've got 1 minus 5, which gives me minus 4. And this is all equal to 0. So like we said, we've got our quadratic equation now in terms of y. So what we want to do here now is we want to solve this quadratic equation. And remember, for a quadratic equation that is equal to 0, we just want to factorize this, okay? Now it's worth mentioning here that not all of these quadratic equations will necessarily factorize. Now for this video, they will, but you'll see in the exam revision that we do for quadratic simultaneous equations, they won't necessarily all factorize, okay? Now, everything is a multiple of 2 here, so what I can do is divide by 2. So that's going to give me y squared plus y minus 2, and that's equal to 0. And what we want to do here now is factorize from here. So we're going to get y at the front of both brackets. This is equal to 0. Two numbers that times give me minus 2, but add to give me positive 1. So that would be plus 2 and minus 1. Okay, so let's just double check. Y squared minus y plus 2y gives me a positive y, and then minus 2. Perfect. So this gives me two y solutions now. And notice this is why we get our two solutions here. Okay, so one of the solutions will be y equals minus 2. And my other solution will be y equals 1. Okay, so notice here now, if we look at this graphically, this will be my minus 2 here. That's minus 2. And this is my 1 here. Okay, so that's y equals 1 there. Now, once we've got our y coordinates, we also need the respective x coordinates. So if we think about this now, I've got my y coordinates and we want the x coordinates, and I just need to substitute this back into one of these equations. Now, it doesn't really matter which of the two you substitute it into, but it makes a lot more sense to substitute this into equation 2. You can substitute it into equation 1 if you like, but it's a lot more work than just doing equation 2. So sub now back into equation 2. So we know x is equal to y plus 1. So let's do this over here. We'll clear all this when we come to look at the second example. So x is equal to y plus 1. So if y is minus 2, then x is equal to minus 2 plus 1, which would give me minus 1. So when y is minus 2, x is equal to minus 1. Okay. And that makes sense when we look at our diagram here, when y is minus 2 and this is minus 1 across the x-axis. Okay. And when when y is positive 1, so when y is positive 1, what do we get here? Well, x is equal to y plus 1, so x is equal to 1 plus 1, giving me x equals 2 there. Okay. And again, if we take a look at this, that makes sense, right? When we look at this here, that's 2 units along, that makes sense. And there we have it. So them are our solutions. So it makes sense if we just give the solutions here at the bottom now, just make those clear. So our solutions here, when x is 2, don't really matter which way we present this, when x is 2, y is equal to 1, and when x is equal to minus 1, y is equal to minus 2 there. Okay, and those are our solutions, and there we have it. So that's the solution to the first example. Like you can see, these questions are a lot of work, so you've got to be very careful. Okay, so that's the solution to the first example. Do take a note if you haven't got this already, but what we'll do now is we'll just clear the screen just so we can see the second example. Now for the second example, again, pretty similar. We've just got the equation of a circle here, and then we've got the equation of a straight line. And again, I just want to solve this algebraically. So what I'm going to do here now is use substitution. Now in this case, neither y or x are the subject, so it's completely up to us which way we do this. In the last example we already had x as the subject. So for this one, let's just make y the subject, just to make it clear that it doesn't matter which one is the subject. So I need to rearrange equation 2 here. So that's equation 2. This is equation 1. So I'm going to write equation 2 here as y equals x plus 3. Okay, so y is equal to x plus 3. And what I want to do here now is substitute y equals x plus 3 into equation 1. So what I'm going to get then is x squared plus y squared. So if y is x plus 3, x plus 3 all squared, and that's equal to 17. So we need to expand these double brackets here, so we get x squared at the front. So this is x plus 3 times x plus 3. You don't have to do the double brackets if it's already clear to you, but I just want to make it clear that this is double brackets here. We could have subtracted 17 off as well in this step, but let's just expand this first. So what I'm going to get here is x squared at the front. X times x would give me another x squared. We've then got x times 3, so that's 3x. And then we've got 3 times x again here. So that would be 3x plus 3x giving me 6x. And then finally we've got 3 times 3, which is 9. Okay, so I've got 9. And we're also going to subtract the 17 off. So remember, we want this to be equal to 0 here. So we subtract 17 off both sides. And that's equal to 0. So what I want to do here now is simplify, collect like terms. So x squared plus x squared is 2x squared. I've got 6x here. There's no other x's, so that's fine. That's its simplest. That's already in its simplest form. And then we've got 9 minus 17, and that will give me minus 8. So we get minus 8 there. Okay, and this is all equal to 0. And again, notice here now, the beauty of this is that we've got a quadratic equation that's just in terms of x now. And again, what we want to do here is just see if we can factorize this. Remember, always check first if you can factorize. And this one does. But before we do that, everything is in terms of, all right, everything is a multiple of 2 here. So let's divide by 2. So we get x squared plus 3x minus 4. That's equal to 0. And now we are going to factorize from here. So two numbers that give me, or times together to give me minus 4, and add to give me positive 3. We can do x plus 4 and x minus 1. That should work. Let's just double check this. X squared minus x plus 4x, that's 3x, and then 4 times minus 1, minus 4. Perfect. So we can identify our 2x solutions here. Therefore, x is equal to minus 4, and x is equal to positive 1. Okay, so we've got our 2x solutions now. And again, just like we did for the previous example, at this point here, what we've got now is 2x solutions. At this point on the previous example, we had 2y solutions, but it doesn't matter. All we do again is we just substitute these x values into equation 2. So let's do that right at the top up here. So y minus x is equal to 3. So y minus x is equal to 3. And what we want here is y. So let's make this, we've already got it here. Y is equal to x plus 3. So y is equal to x plus 3. So in that case, if x is minus 4, so when x is equal to minus 4, then y is minus 4 plus 3, which gives me minus 1. Okay, that's our y solution there for x equals minus 4. And when x equals positive 1, when x is equal to positive 1, we get y equals 1 plus 3, giving me 4 there. Okay, and there we have it. So those are our solutions there. Let's just highlight that in a different pen color. So I've got my first set of solutions there. So when x is minus 4, y is minus 1. And when x is equal to positive 1, y is equal to positive 4. Okay, and there we have it. So that's the solution to the first two examples. And now it's your turn. So have a quick look at this question on the screen here. Remember, we just want to solve this algebraically, so we need to use substitution. Pause the video now, have a quick go, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with this practice question. Let's take a look now at what you should have got. Well, again, all we want to do here is just solve this algebraically. So what I need to do is substitute either x equals here or y equals. Again, it's completely up to you. It's just a preference thing. In this case, let's just make x a subject. It really doesn't matter. So this is equation 2. This is equation 1. So we can make this then as x a subject. So that would be y minus 2. Okay. So what I need to do now is substitute x equals y minus 2 into equation 1. So what's that going to give me here? So that's y minus 2 all squared plus y squared. And then that's equal to 10. Expanding these double brackets here, so that's y minus 2 times y minus 2 plus the y squared. This is equal to 10. Expanding these double brackets now using FOIL or any method that you're familiar with, so I get y squared. I've got y times minus 2, so that would be minus 2y. But again, we repeat that here, so minus 2 times y, so we get another minus 2y. So minus 2y minus another 2y, that gives me minus 4y. I've then got minus 2 times minus 2, which would give me positive 4, so just be careful with your signs here. We've also got y squared. And again, we want this to be equal to 0, so I'm going to subtract 10 off both sides. Okay, and that's equal to 0. What I want to do here now is simplify and collect like terms. So y squared plus y squared, that gives me 2y squared. Minus 4y, there's another y's, so that's its simplest form there. And we've got 4 minus 10, and that's going to give me minus 6. Okay, and this is equal to 0. Again, notice everything here is a multiple of 2, so we can divide through by 2, and I get y squared minus 2y minus 3 is equal to 0. And from here now, what we want to do is factorize if we can. So if we factorize this here, we're going to get a y at the front of both brackets. Y at the front of both brackets here. This is equal to 0. Two numbers that times give me minus 3, but add to give me minus 2. What would that be here? Plus 3 or minus 3 plus 1. And that should be the 1. Minus 3 plus 1. So let's expand this. Y squared. We get y times 1, so that's y. Minus 3 times y, that's minus 3y. And then minus 3 times 1, that gives me the minus 3. Perfect. So everything works out there. Good. So now we can get our two y solutions here. So y is equal to positive 3. I've also got y equals minus 1. We've got our two y solutions. Now we can obtain the two x solutions. We finish that up here. So when y is equal to 3, well, we know x is equal to y minus 2. So x is equal to y minus 2. What I get here for x then is 3 minus 2, giving me 1 there. Okay, so when y is equal to 3, x is equal to 1. And when when y is equal to minus 1, then y is equal to minus 1, then x is equal to minus 1, minus 2, giving me minus 3 there. Okay, and again, let's just highlight that these are our solutions. So this solution here, and I've also got this solution here. And there we have it. So that's our solution, and that brings us to the end of this video. In the next video, we're going to take a look at solving quadratic simultaneous equations graphically.